Okay, so let's do 6.2, the binomial probability distribution. Now, in order for something to qualify as a binomial probability experiment, the experiment has to be performed a fixed number of times, with each trial being, or each time you do it, is called a trial. Every trial is independent, means the outcome of one trial will not affect the outcome of the others. And for each trial, there's exactly 2 disjoint outcomes. So it's like flipping a coin. It's either heads or tails. And you're like, well, what about something like rolling a dice? This can be done with rolling a dice. You just need to call an outcome, say, rolling an even versus rolling an odd. Those are distinct. Rolling a 6 versus not rolling a 6, 2 outcomes. The probability of success needs to be fixed for each trial. Which of the following are binomial experiments? A player rolls a pair of fair die. The number of x of 7s rolled is recorded. So the number of sums, I guess, of their dice to 7 is recorded. Okay, so is it performed a fixed number of times? Yes. Are all the trials independent? Do your rolls from one carry over to the next one? No, so they're independent. For each trial, are there exactly 2 outcomes? Either they did roll a 7 or they didn't, so that's 2 outcomes. And the probability of success is fixed. It is, in fact, fixed. You have a certain amount of chances to roll a 7. So is this a binomial experiment? Yes, it passed all the criteria. The 11 largest airlines had an on-time percentage of 84.7%. In order to assess the reasons for delays, an official with the FAA randomly selects flights until she finds 10 that were not on time. The number of flights that need to be selected is recorded. Okay. Question 1, is the experiment performed a fixed number of times? Okay, well, she needs to find 10 that are not on time. That could take only the first 10 planes if it was a really bad day. But what if it took like 300 planes because they had a good day? That is not a fixed number of trials. So this is automatically no. You don't even have to ask yourself the rest of the questions. Are the trials independent? Maybe. You could argue that different times of day, different airports may have a greater or lesser chance of being on time. Are there only 2 outcomes? Yes, it's either on time or it's not. Is the probability of success fixed? Not really. In a class of 30 students, 55% are female. The instructor randomly selects 4 students. The number of females is recorded. Is it performed a fixed number of times? Yes. Are the trials independent? Well, we'll get back to that. For each trial, there are 2 mutually exclusive events. Yeah, it's either female or it's not. Is the probability of success fixed? Okay. So 55% are female out of 30. What happens if she picks a female? That number goes down because there's 1 less female to pick from. It doesn't really say pick and replace. So I would say no, not independent, because picking a female changes your percentages. And the probability of success is fixed. It's not fixed because it's not independent. Like 2 and 4 kind of go together. Can't have one without the other. So notation used in a binomial probability distribution, there are n trials. P is the chance of succeeding, which means 1 minus P is the opposite, the probability of failure. X is a binomial random variable that determines the number of successes out of n. So let's say if you have 10 trials, you may have like 8 successes. The only thing you know is you can't have more successes than trials. I can't say I rolled the dice 10 times and I rolled 12 sixes. Wouldn't make sense. So point out each notation, and for this binomial distribution, a fair coin is tossed 3 times. Let X denote the number of heads. So we have 3 trials. What are the chances of getting a heads? 0.5. Well, what's 1 minus 0.5? My chances of getting a tails? 0.5. And X, we don't know. We don't know how many heads we got, but we know that it has to be between 0 and 3. Now here is the function. The probability of obtaining X successes in n independent trials of a binomial experiment is given by the probability of X equals n choose X times p to the x power times 1 minus p to the n minus x power, where x is some number between 0 and n. So this looks scary. It's not. A fair coin is tossed 3 times. Find the probability of tossing exactly 2 heads. So n is 3, x is 2. 2 heads out of 3 rolls. So the probability of 2 is equal to 3 choose 2 times my p, which we know from above is 0.5. 0.5 squared, because it's p to the x and x is 2, times 1 minus p, which we know also is 0.5, to n minus x. N minus x is 3 minus 2, which is 1. So 3 choose 2, you can put it in your calculator, that's 3. This is times 0.25 times 0.5. This whole thing is 0.375, or 3/8. And this is consistent with, if we look at the table to the right, how many of them have exactly 2 heads? We've got heads, heads, tails, heads, tails, heads, and tails, heads, heads. So 3 out of the 8 possible options. So this shows the formula does work. And there'll be times where you're doing more than 3 and your percentages or probabilities aren't nice. So you really want to be able to use the formula. On the test, if you can't use the formula and you try to write everything out, you will run out of time. So we can ask more than exactly 2 heads. We could say at least 2 heads, at most 2 heads. There's a lot of different questions we can ask and therefore answer. So here are some how the words translate in some way to meaning and what we're going to have to do. Things like at least and no less than and greater than or equal to, or the greater than or equal to symbol. More than or greater than without the or equal to is just greater than. Fewer than, less than, similarly it's a less than or no more than, at most, or less than or equal to has the equal to sign included. And then exactly just means equals. And we will continue in the next video.